Right. So we filled this out already. This is what the question was like. Shade in the region which represent A to section B. That means where they cross over. So that's where they cross over. The next question. What is A union B? So A union B means all of A and all of B, which is that. Next. On the Venn diagram, shade in the region that represents A union B less without A intersection B. Right, so first of all, A union B is all of it. This symbol here, L, I call it less, with or without. So this symbol here, I call it, so A union B, all of this, but without A intersection B. So let's say I don't want A intersection B shaded. So all of A and B, but I don't want A intersection B shaded. Okay? Next one. Put a tick in the correct box to show which of the following represents the elements that are in A but not in B. So A, elements that are in A but I don't want B. So that would look like this. So I call this one A, but I want A but I don't want any of B. So that would be A, but I don't want B. Alright? And that would be this one here. A, and I don't want B. So if you could draw that in yourselves there on your sheet. A, but I don't want B. Do you see that? Are you looking up? Draw that in your sheet. A, but I don't want B. Next page. Question 2. Set S is shown in the Venn diagram below. It has 5 elements. So A, so Anthony, Bart, Declan, Kieran and Owen. Some students are asked to write down subsets of S that have 3 elements each. Owen writes down the subset A, C, D. So subset is part of the set. Okay? So a subset, where are we there? A subset is part of the set. How many parts do we want? How many elements? These are called elements. How many elements do we want to write down? So basically you can pick any subset that you want. So give me an example.
A, B, C.
Not 1, 2, 3. You have to use the letters.
A, B, C.
A, B, C. Give me another random subset.
C, D, U, C, B, E, D.
What do you want? B,
D.
B, D, and we'll go for E. All right. Who's that? So this person writes down A, B, W. Is W an element up here?
No.
So is she right? Fiona, I think it is. Explain why this is not a subset. So W is not an element. W is not an element of the set S. So this cannot be a subset. It's wrong. W is not an element of the set S. Question 3. John is asked to give an example of a set. He said, the set of good websites. Explain why this is not a set.
Well, the person who asked John is like he wanted mathematically like an element, but he just said it with websites randomly.
Okay, he said the set of good websites. So it's probably not a good idea because some people think that some websites are good. Some people may think that those websites are bad. So it's hard to pick them out, isn't it? Plus, there are a lot of websites out there as well. So it's not a clearly defined set. It's not easily defined, that set. The set, we'll go on to the next one. The set U, A, and B are defined as follows. So U are the numbers, this U is the set U are the numbers from 1 to 10. A is the set of multiples of 2 from 1 to 10. So what's A equal to? The multiples of 2. 2, 4, 6, 8, 10. Set B, the multiples of 3 from 1 to 10.
3, 6, 9.
3, 6, 9. That's it. Okay, if I was to ask you, I'm just going to make up another set for myself. The set is the prime numbers from 1 to 10. Prime. 2, well done. 2, 3, 5. 9 is not, because 9 is divisible by 3. That's it. Well, from 1 to 10. Okay, so we don't need this in the question, but we did it anyway. Okay, use these sets to fill in the diagram. So A, we have to fill in. So first of all, this is the common area. So we're using A and B. So there's A and B. Right, there's a common area. If you look up. There's a common area in the middle. So what numbers is there any number in common?
6.
Okay, common. So 6 goes in the middle. Alright, and we look at A and everything else goes on the left. 2, 4, put a dot, 8, dot, 10, dot, put a dot, because they're elements. And 3, dot, and 9, dot. The dot shows that they're an element. Okay? Using your Venn diagram, find the smallest number that is both a multiple of 2 and a multiple of 3. 6. Six is the answer, isn't it?
Yeah.
Next page. Question 4. As part of a survey, 35 students. Now look up. So that's everybody. All the students in this box. 35. I want to see you writing. Are asked if they like Rihanna. So Rihanna is R. So how many students like Rihanna altogether here?
9.
How many like Rihanna but not One Direction? No, how many like Rihanna? 9 and 12. That circle is Rihanna. 9 and 12 is 21. How many like Rihanna but not D, not One Direction? 9. Some of the results are shown in the Venn diagram below. Right, so 35 is the total. 6 out here like neither, they don't like Rihanna and they don't like One Direction. Alright, so 35 is the full box. So we got 9 plus 12 is 21 plus 6 is 27. Then we need 35, yeah, minus 27 is 8. Okay. So that means 8 people like One Direction, but not Rihanna. How many people like Rihanna and One Direction? 12. How many people like Rihanna or One Direction? If you say or, then that's the same. You can add them all up.
27.
Yeah, 27. So this is Rihanna or One Direction. is 27. Rihanna and One Direction is 12. Alright, so and means, what does the word and mean? So Rihanna and, the word and is important. And One Direction is the same as writing Rihanna intersection D. Same thing. Rihanna or One Direction is the same as writing Rihanna Union D. Okay? Right. And over here, this 9 here, this 9, how do I write that? Is that Rihanna? That's Rihanna without One Direction. How do I write that? Rihanna, but not One Direction. Alex? Well done. Or slash, we'll call it D. Alright, so Rihanna without any One Direction is 9. What's this one over here? 8. What does the 8 represent?
D/1.
D. So One Direction without any of Rihanna. That's very good. Okay. And R intersection D is 12, isn't it? We did this one already. R union D
27.
is 27. We'll do one more. R union D less. So it's the same as the slash, alright? What does that mean? So that is the same as that line there. Yeah. So R union D, everything outside of R union D, which is 6. That's what that means. Okay, so what would R intersection D? So that's the R intersection D is 12. So everything outside of that
23.
is 9 plus 8 is 17 and 6 is 23. Do you understand this? Complete the Venn diagram, which we did. We had to add 8 there. How many pupils like One Direction? So One Direction, all of One Direction? 20. The next question. Shade in the region of the Venn diagram which represents R less D. So, or in case you can't see it, R less D. So R, but not any of D. That's the shaded region. Describe in your own words what the shaded region represents. So in our own words, people who like, yes, people who like Rihanna, but not One Direction. People who like Rihanna, but not One Direction. Okay. All right. So again, same type of question as question 1 that we did earlier. A union B shaded in. So go on. I'll give you all of it, isn't it? On the Venn diagram below, shade in A, but not any of B. A less B. A, but not any B. Just tell me when to stop. Yes. So A, but none of B. Now the next one. So you have to break it up. A union B is all of it, first of all, isn't it? See this bit here? It's all of that shaded area. but I don't want, see this line here? I don't want A less B. So we have to work out what A less B is. So we'll do it over here. We'll work out what this bit is. What is A less B? So A without B. That's A less B. Okay? So this bit here, A less B, that's what it looks like. Right, so we'll start again. A union B, I want to shade in all of this, but I don't want to shade in this bit here. So I can shade it all, but not that bit. So that would mean that I can shade in this. Okay, so this is the answer here. Will I go through that again? Right. First of all, A union B means all of it. Alright? This line means, but I don't want to shade in A less B. So over here, we figured out what A less B is. A without B. So basically, I want to shade in as much of this as possible, A union B, all of it, except this bit. Alright? Do you understand that?
Yeah.
Sure? Next one. If A represents the students in a class who like apples, and B represents the students in the class represents the students in the same class who like bananas. So apples and bananas. So write down what the set A less B represents. So A less B. So A, but not any of B. So there you go. What does it mean? It means people who like apples, but not bananas. Okay? Now, because this is recorded, we have to keep moving. There's lots of good questions in this, and these are very good questions for studying for your test. Sports. So the girls, what do the girls play? The girls play camogie, hockey, tennis, basketball, football. The boys play hurling, rugby, tennis, basketball and football. What games do the girls and boys play? Tennis, basketball and football. Describe the region of the diagram where camogie and hockey are located. That region. This region here. What's that? There. G. G, but not yet. G without any of B. Describe the region of the diagram where tennis, basketball and football are located. Alright, and the next question would be, if it was there, it's not. Describe the region where hurling and rugby are played. B. So that's B without any of G. So hurling and rugby is B less G. Right, C. In the Venn diagram, shade A union B. All of it. In the Venn diagram, shade the set A union B less. See that that little dash also means that, basically. Right. So A union B is all of in the circle here. It's all of that. A union B. But what is less? So outside, but not. So A union B, and then this dash means everything that's outside of that. So I actually get to fill in the opposite of A union B, which is this. So A union B less means that area there. Alright, so if I drew another, what does A intersection B less mean? Are you looking up? Should be writing. Are you taking these notes?
Yes, sir.
A intersection B less means, well, A intersection B is in the middle here, but less means the opposite. What's outside it? So the only bit that's not shaded is A intersection B. So A intersection B less means everything outside of A intersection B. I want to see people taking note. Right, question 7. The natural numbers from 1 to 10 inclusive. So U is the numbers from 1 to 10. So 1 to inclusive means every one. So all of these elements are inside this box. K are the factors of 6. What are the factors of 6?
1, 2, 3.
Yeah, numbers that divide into 6. 1, 2, 3 and 6. L are all the even numbers.
2, 4, 6, 10.
Okay, so the first thing we have to do before we fill this in, this is the common area in the middle. What's common to both sets? 2 is common.
6 and 10.
And 6 is common to both. So 2 and 6. 2.6. The dot means it's an element. 6, the dot, right. So then we fill out the K's, 1 and 3, go there. And then the L's, 4, 8, 10.
Then you have to do
And then the rest is outside.
Did we miss it?
5, 7.
5, yeah, 5 is not included in either set. Very good. 5, 7 is not included.
15.
9. That's it, well done. Right, here's some other questions. Here's a question. Is there's the question. Is 1, and I put it in brackets to show that it's an element, is 1 an element of K? So true. Is an element of L? Is 1 an element of L? Look it up.
No, false.
1 is over there. It's not part of L. False. Is 2 an element of K union L?
Yeah.
Yeah, K union L is all of these numbers up here. Is 2 an element of it? Yeah. Is 4 an element of K intersection L? K intersection L is 2 and 6. It's false. Another question. Another, so that's element of. Okay. Is 9 an element of L?
False.
Okay, that's false, isn't it? So I can also change the statement slightly. 9 is not an element of L. Is that statement true now? Okay. Now, contained in is the element 3 contained in. That means, is it inside? You are contained in this room. Is the element 3 contained in the set K?
True.
Is it inside K?
Yeah.
Contained inside? It's true. Right. Is 1, 2, and 3, are those elements contained inside K?
False.
1, 2, and 3. Are they inside K?
Yeah.
The set K? It's true. What I could say is 1, 2, and 3. I could also say 1, 2, and 3 are contained in. Okay. So that was true. I'll do another example. Is 1, 2, and 3 contained inside L?
False.
False. So I could also rewrite the statement and I could say 1, 2, and 3 is not contained inside L. Right?
Yeah.
And one more. Is 2 and 6 contained inside K less L? What's K less L? K without L.
False.
Is 2 and 6 contained inside that space?
False.
1 and... Or I could just write 2 and 6 is not contained inside K less L. Right, so some of the questions below. K intersection L is... Now, this blank, what does that blank mean?
There's nothing.
Yeah, null set, it's called.
No set.
It can also be written as, That.
Circle. And
or you
cross.
can write it as just
Circle.
null set. So 3 options. That's 3 ways of writing null set, alright?
That's it.
Okay. So K intersection L, null set is empty. That means that there's no answers. So K intersection L, what is the answer?
False.
K intersection L is actually, what is the answer? The answers are 2 and 6. So here they're saying K intersection L is blank. There's nothing. There's no answers. But the actual answer is 2 and 6. So that's false. Reason? Well, this is the reason. K intersection L is equal to 2, 6. Right, the next one. K is not equal to L. Is that true?
Yeah.
K is 1, 2, 3, and 6. L is 2, 4, 6, 8, 10. That's true. The reason? K is equal to 1, 2, 3, 6. L is equal to 2, 4, 6, 8, and 10. Hello? All right. Yeah. I will. Yeah. All right, we'll do another question here. K union L is equal to the universe. The universe. That universe is everything inside. It's false, isn't it? Why? Because K union L is equal to everything inside the box, which is here. 1, 2, 3, 4. Hold on, we'll have a look at it. 1, 2. K union L is everything inside the circles. 1, 2, 3, 4, 6, 8, and 10. 1, 2, 3, 4, 6, 8, and 10. What's the universe? Was everything 1 to 10. Are they equal? They're not. Okay. Right, we'll do a question, finish off the question. The universal set, so it goes 1, 2, 3, 4, 5, 7, 10, 11, 13, 17, 19 and 20. A is a set of prime numbers between 1 and 20. It's all the prime numbers. 1 is not a prime number. 2 is. 3 is. 5. It's only divisible by 1 and itself. 7. 10 is divisible by 1, 2 and 5, isn't it? So that's 3 divisors, so that's not. 11 is divisible by 1, only 1 and 11, so that's a prime number. 13 is only divisible by 1 and 11.
17 and 19.
Only divisible by 1 and 17, only divisible by 1 and 19. 20 is divisible by 1, 2, 4, 5, 10 and 20. Right, this is the elements of set B. B is a set of factors. So 1 is a factor of 20. There's 2 divides into 20. 4 divides into 20. 5 divides into 20. 10 and 20 itself. Fill in the diagram. So first of all, the first thing we have to concern ourselves is the middle bit. What's common to both? There's 2 common to both. There's 4. No. There's 5. There's 10. No. There's 20. No. So we write the thing that's common to both in the middle first. 2.5. Now, A, so A is the rest of them. 3, 7, 11, 13, 17, and 19. 3, 7, 11, 13, 17, 19. Right, B is 1, 4, 10, and 20. Okay, so then this question becomes easy. List the elements of A intersection B, the middle section. Complete the sentence below. If an element is in the region A intersection B, it has 2 properties. It is a prime number and it is, what is it? It's a factor. Both are factors of 20, aren't they? It is a factor of 20. So if the number is in the middle, it's a prime number and it's a factor of 20. Because where do you get that answer from? You get it from up here. Prime number, and there are 2 keywords in those sets. So they're the things that have to be in common. So the things that are in common go in the middle. So that's what they have in common. They are prime numbers and they are factors of 20. Alright? The number 16 is added to the universal set. Place 16 in the correct region in the Venn diagram in part C and explain why you placed it there. So, is 16 a prime number?
No.
So we don't put it in set B. Is it a factor of, does it belong to A?
No.
It doesn't belong to B.
No.
So it doesn't belong to A, 'cause it's not a prime number, it doesn't belong to B. So you put it outside of both sets. So remember, these are prime numbers. These are factors of 20. So 16 has to go outside. There's nothing in common with either of those. So the reason, so 16 does not belong to A. because they are prime numbers, and 16 does not belong to B. Factors of 20.